Hello, today's lesson 4.5, is all about direct variation. We're going to take a step back and relax a little bit. We've been talking about slope-intercept form. Direct variation is a version of that. Two vocabulary expressions today, direct variation and constant of variation. Please write those down and we'll come up with our definitions for our notes of those. Direct variation. Let's talk about this situation. It says a recipe for paella calls for 1 cup rice to make 5 servings. So we have a ratio right off the bat. In other words, a chef needs 1 cup of rice for every 5 servings. So if we double that, of course, we're going to double the servings. We look at this equation. What would represent rice versus servings? And we understand that servings depends on the amount of rice we cook. We know that 5 times the number of cups of rice yields servings. In this relationship, the number of servings varies directly, and we're going to look as to why. Direct variation is a special type of linear relationship that can be written in the form y equals kx, where k is a non-zero constant called the constant of variation. If we go back here for just a second, we can see our equation is y equals kx. So you guys can understand that our variation is 5 in this case, our constant of variation. Example 1a says, tell whether the equation represents direct variation. If so, identify the constant. Well, we were just told that y equals k times x. K is our constant, so our constant in this situation will be 3. How do we know it's direct variation? Because the equation follows our form y equals something times x. Tell whether this equation represents direct variation. Well, let's solve for y. If we subtract 3x from both sides, we see that y equals not only kx, but kx plus some other value, and we'll call that our constant. In this form, we could understand or see that it is similar to y equals mx plus b. It's not in the form y equals kx. Excuse me, just a second. It is in the form y equals kx plus b. So we would say, no, it is not in direct variation. Tell whether this equation is. We see 3 terms again, but I notice one of them is 0. If we add 4x to both sides, we get 3y equals 4x. We can isolate y by dividing both sides by 3, and we can see y equals kx. Our constant of variation is 4/3, and it is direct variation because it falls in our form y equals kx. In Check It Out 1a, I'd like you to do this problem and come back and see what you got. Tell whether it represents direct variation. If so, identify the constant. Well, this is like the first exercise that we did. We can see that if we isolate y, we're going to divide everything by 3. We get y equals 4/3 x. If we didn't have this 1/3 on the end, we could see that it was in direct variation. But because we're adding a constant term, this equation is not direct variation. It does not fit in the form y equals k times x. Try Check It Out 1b. Come back and check your answer. So let's go ahead and solve this one for y as well. Dividing both sides by -4. We get our simplified version, y equals something times x, plus nothing. There's nothing on the end. It's in the form y equals kx, and our constant of variation is -3/4. Let's try Check It Out 1c. Now I'll give you the shortcut. If I see 2 terms and no other term other than 0, we have direct variation. In this one, we're simply going to subtract 3x from both sides, getting our equation y equals negative 3x. This is direct variation, and our constant is negative 3. What happens if we solve y equals kx for k? Well, we get our simplified version of k dividing both sides by x. We can see that y over x is equal to our constant. And this is how we can look at a table to figure out our ratio or our constant of variation. That's what we're going to do here. Remember, y over x is equal to k. We're going to take our y value each time and make a ratio, y over x. Our first one would be 6 over 2, then 12 over 4, and 18 over 6. All of them simplify to 3. 3 is our constant of variation. In example 2a, it says tell whether this is direct variation. Find y over x. That's what we just did. We can see that we have a constant value, y over x, of 3 each time. We can write the equation then, because we know it's in the form y equals kx. Let's look at this one. If we take the value, negative 2 over 1, that's negative 2. 0 over 3 is 0, and 4 over 7 is 4/7. We do not have a constant ratio. We can see that if we take the x value and subtract 3 each time, we get our y value. Therefore, it is not in direct variation. Check it out 2a. Tell whether this relationship is direct variation. Recall that y over x has to be the same each time. And I see 0 over negative 3, 3 over 1, and 6 over 3, none of which are equal. Not direct variation, because y over x is not the same for all ordered pairs. Let's try check it out 2b. And we're going to write the equation. If I take x each time and multiply it by negative 4, I can see that I get my y value each time. The other way is to take y over x and simplify, and that would give us our negative 4 constant of variation. How about 2c? 3 over 1 is 3. 1 over 4 is 1/4. We already know it is not in direct variation. The value of y varies directly with x. Y is 3 and x is 9. We know that these numbers have to fit into our function y equals kx. We have an x value and a y value, and if we substitute those in to our function, we can solve for k. Dividing both sides by 9, k is 1/3. It says find y when x is 21. We're going to rewrite our function, y equals 1/3 x. When x is 21, we're going to take 1/3 of 21 and locate our direct value, 7. Now you try. We can use a proportion. We can say that 3 over 9 has to be the same as something over 21. That's our missing y value. And if you remember proportions, we simply want to cross multiply and divide. 9 times y equals 3 times 21. Dividing both sides by 9 yields our same constant, 7. You try, check it out, example number 3, and come back and see how you did. So let's go with our same thing. Let's come up with the equation when y is 4.5 and x is 0.5. Let's find our value, k. We're going to substitute those in. Y is 4.5, x is 0.5. Dividing both sides by 1/2, we get k equals 9. Coming up with our equation, y is 9x. That is our constant. Y equals 9 times x. So when x is 10, y equals 9 times 10, or 90. We can also use the method of coming up with a proportion. y over x is the same as y over x. Our missing y value is the numerator of the second ratio. We're going to cross multiply and we get 45 equals 0.5 times something. That something would be 90. Half of 90 equals 45. To graph direct variations, we need to understand one thing. This function always goes through the origin. We're going to come up with our equation. Distance is y, miles per hour is our constant of variation, and x is our variable. We're going to generate a table. And we see at x hours, our distance is 0. At 1 hour, we are 2 miles down the river. And we're going to graph that. Notice it passes through the origin and the other values are good. Please go ahead and check it out, example 4, and come back and check your answer. So it says the perimeter of y varies directly with its side length. Perimeter of a square. Square indicates that all sides are the same. So we notice if we take its side length and multiply it by 4, we'll get our perimeter. Perimeter is 4 sides times the length, which is the same every time. So y equals 4x. We're going to choose values of x and generate ordered pairs. Y equals 4x. We allow x to be 0, 1, and 2. So a square with side length 0 will have a perimeter of 0. Notice it passes through the origin. If the side lengths were 1, perimeter's 4. If the side lengths are 2, 4 times 2 generates 8 for our perimeter. Go ahead and check out your problem set on PowerSchool and meet back here for lesson 4-6 tomorrow.